Okay, students, now I will talk about the acceleration, the constant acceleration, and how to apply the equations of motion. We will see them. There are 4 or 5 equations. We will apply them, and I think they will be easiest to be applied. Okay, I need to start these examples. I have many sheets now. I will start them by mathematics. What if I have a function f of x is equal to y, and I need to find the value of this f of x or y at x equals 7? The function is 3x minus 5x squared plus 2x cubed. It is easy. I just use 7 and put it in each x, which is equal f of 7 is equal to 3 by 7 minus 5 multiplied by squared 7 plus 2 multiplied by cubed 7. This is equal to minus this will be equal to 462. This is f of x, which is equal to y. This is mathematics. There is no units. I don't need any unit here. Okay, what about this? This is x of t. It is another function. The name of the function is x, and the dependent variable is x, and the independent variable is t. I can now name x as a position and t as a time. In this case, I can convert this equation or understand it in physics vision or something like that. Okay, I need x at t equal 2 seconds. I can put 2 in t. Okay, so I need x of 2 is equal to 3 plus 5 multiplied by 2 plus half multiplied by squared 2. In this case is equal 3, 10. This is 10. 3 plus 10 plus half multiplied by 4 is 2. This is equal to 15. It is x. It is position. Now I can put the value of the unit. This is x of 2. I can apply that for the velocity. I can use velocity as a function of time, and I can use any function that I need. Look at this, 120 over t plus 5 exponential minus 15t, and I need the time at t equal half. Just I need to put half in t. Also, I can compute the acceleration at t equal 15. Just I need to put 15 in t each time. This is sine. This is ln or ln. This is pi. Pi in this case is 3.4, something like that. I think it is easy to substitute the value of the time in each function. Now I will move to the next part. Now, if I see here, there are no relations between my functions. This one is mathematics. This is I need to compute the position. There is no relation between this position and this velocity and this acceleration. Now I need to use acceleration and position and velocity for a body, for one body, and I need to find the position and the acceleration and the velocity at t equal 15 seconds. I can compute now directly the acceleration. If I need to compute the position, I need to find v of t and multiply it by t. I know t is 15. I need also here the acceleration. I don't know the acceleration. V, I don't know. I don't know here. This is typo. No, not a typo. I'm sorry. This is t multiplied by the acceleration. I am sorry. This is equal to t multiplied by the acceleration a of t plus 5. Okay. I will be care later about these things. Okay, I need now to compute the acceleration. The acceleration at t equal 15 is equal to 12 over 3 multiplied by 15. This will be equal to 0.267. What is the unit of the acceleration? It is meter per squared seconds. Okay, now I can compute the velocity. Velocity at t equal 15 seconds is equal to t, which is 15, and multiplied by the acceleration at t equal 15, and I compute that, which is 0.267 plus 5. All of this will be equal, the velocity at t equal 15 seconds is equal to 20.267. What is the units of the velocity? It is meter per seconds. Okay, now I can compute and find the position. It is equal to x at t equal to 15, 3 plus v at 15. This is v at 15. It is 20.267 multiplied by t. T is 15 also. It is the same time for all of them. Plus half a of t. T at 15 seconds. The acceleration at 15 seconds is this value, which is 0.267. I can find the position now. It will be 3 plus half multiplied by 0.67. Okay, go to, it will be I'll be sure, yes, 307.01.385. What is the units of x? It is meters. Now I will talk about these equation of motions. We have 1, 2, 3, 4, 5 equations. I will not go how can we derive them. There are two ways to derive these equations. One of them is using algebra and you will see how uh, we can derive them during watching the videos. And there is another way, which is using calculus and integration and derivation. I will not go through that. What I need to know, and with what is more important, how to apply these equations. Look at this example here. I have two cars. The first one at three positions have the same velocity. The velocity is constant. It is 10 minutes by second, 10. And the acceleration in this case is constant and equal to 0 meter per square second. Okay, but the other car changes its velocity. Look here, this velocity is 10, this velocity is 20, and this is 30. So I have acceleration not equal to 0 in this case. Do you think the position of the constant velocity car is the same as the accelerated car? No, the accelerated car will pass more distance or displacement when it moves, because it has acceleration, its velocity increase. So the position is different than the first one. Okay, I will solve now this example. I need to find the position for the cars at each given time. I have 3 times: at t equal 0, at t equal 5 seconds, and at t equal 10 seconds. Okay, for the first car, now I will start to calculate the position for the first car. I have the velocity and I have the times. I know the law of velocity. Velocity or average velocity is equal to the change in position divided on the change in time. So I need to find the position, which is delta x, which is the change from the initial velocity position to the final position in from A to B and from A to C. I need to find it twice. Now for B, delta x from A to B is equal to the velocity, the average velocity, multiplied by the time period from A to B. Okay, the velocity is 10 meters per second, multiplied by the time is 5 seconds at B. So the position now at B is equal to 50 meters. At point C, the same law. Delta x from A to C is equal to the velocity, which is the same 10 meters per second, multiplied by the time, which is 10 seconds at C. And the final displacement or change in position is 100 meters. So the body is moving, or the car moves from A to B 50 meters, yes, and 100 meters from A to C. Now how can I find the change in position for the second car, which has an acceleration? How much its acceleration? I need to compute its acceleration also. Okay, let us see now. How can we do that? For the next car, I have the time, I have the velocity at each position. So I need to find the acceleration. The acceleration is equal to change in velocity over the change in time, which is equal to velocity final, the final velocity minus the initial velocity, divided by the change in time or the time period. If I take that 2 points A and B, so the acceleration is equal to velocity at B, which is the final point, minus the velocity at A, which is the initial point, and the change in the time between A and B is 5 seconds, delta t from A to B. The velocity at B is equal to 20 meters per second. 20 meters per second minus the initial velocity is 10 meters per second, and the change in time is 5 seconds. Okay, 20 minus 10 is 10 over 5, which is equal, the acceleration now is equal to positive 2 meters per squared second. This is between A and B. What if I need to compute the acceleration between B and C? I'll find it. Vc minus Vb over delta t between B and C. The velocity at C is equal to 30 meters per second. 30 minus the velocity at B is 20. The time change between B and C is 5 seconds because the time at B is 5 and the time at C is 10. So the time change or the time period is 5. Now again, 30 minus 20 is 10 over 5, which is equal to 2 meters per squared second, which is the same. Now what if I need to compute the acceleration or the average acceleration between A and C? It will be equal to Vc minus Va, just like that. I choose the initial and the final points over the change in time or the time period between A and C. This is equal to the velocity at C is 30, the velocity at A is 10, the time period between A and C is 10 seconds minus 0, which is 10 seconds. Okay, that change in velocity is 20 and the time is 10, and this is equal to 2 meters per second squared. Okay, now we compute the acceleration three times during this track, and the acceleration is the same and in the same direction. We see that the direction to the positive x direction. In this case, we can call this acceleration a uniform acceleration or constant acceleration. Okay, the car changes its velocity 2 meters per second in increment in positive direction x direction. Okay, now I compute the acceleration and it is constant, which is equal to 2. Now I need to find the positions. Make it easy. I have 3 equations or 5 equations. I need to find the position at each time. Which equation of them I will use? The first one, I have the acceleration, I have the velocity, and I don't have the position in the first one. I will not use it. The second one, I can't find the position in the second one. I will not use it. The third one, I have the velocities and I have the time, but I don't have the acceleration, so I can't use it. The acceleration in the third one is 0. I don't have acceleration here. What if I have the acceleration? I would use the fourth one, this one. I can find the position, I have the time, I have the acceleration, I have the velocities. I can use this equation. So I will use it. X is equal to x naught. I will write it in different way now. Plus v naught multiplied by t plus half a t squared. If you don't carry these equations, just use a sheet of paper and look at it to write these equations. Okay, if I move the x naught to the left hand side, it will be x minus x naught, or x final minus x initial. X naught is the x initial. X final minus x initial is delta x. Delta x is the change in position. It is the value what we computed for the first car. Okay, delta x, I move this to this side, is equal to v0, which is v initial multiplied by time period. I can put it delta t plus half a t squared, or the change in time delta t squared. Okay, I will compute now the delta x from a to b. So I have is equal to v initial. V initial means v at a multiplied by the time period from a to b plus half the acceleration. The acceleration is constant. All the way the acceleration is constant. It is 2 multiplied by delta t from a to b squared. Okay, v at a, if you remember, v at a for the second car is 10 meters per second. Delta t from a to b is 5 seconds, from 0 to 5, plus half acceleration is 2. The time from a to b is 5, squared is 25. Simply I can cancel 2 with 2, so 50 plus 25, which is equal to 75. This is the change in position from a to b. The unit will be in meters. If you remember, for the first car, from a to b, the change in position was 50 meters, not 75 as the second car. The second car moves 75 because it has extra velocity, extra acceleration. Okay, I need to compute the change in position from A to C. This will be equal to V initial, which is VA, the change in time, or the time period from A to C now, plus half multiplied by the constant acceleration multiplied by the change in or the time period from A to C. Okay, the velocity at A is 10 again, multiplied by the time period from A to C, it is 10 seconds, plus half the acceleration is 2, the time period is 10, squared is 100. I can remove this 2 with this 2. This is 100 plus 100, which is equal to 200 meters. This is the change in position between A and C. So now I can compute the way from A to B. It is 200. From A to C for the second car, it is 200 meters. Okay. In the same way, I can compute the change in position for the car from B to C. I can choose V at B is equal to 20. Delta t from B to C is equal 10 minus 5, which is equal to 5 seconds. And I can use the same equation. I have the V at B, the acceleration is constant, is equal to 2, and that's it. The units of the velocity always meters per second, the time in seconds, and the acceleration meters per square second. Okay, I'll move to the next sheet. It is long now, but please focus to what we need to do. Okay, this sheet, we need to read the question. We have scatter moving at a regular speed. V initial is equal to 1.75. Began to climb up a hill. His movement slowed down because he moving upward. With acceleration -2, minus means that he is decelerating. Okay, and the scatter settled at the end of the level. Settled. What is the mean of this word? How much its velocity or his velocity at the end point or V final? He reaches the stationary, so his velocity will be 0, V final. So I will use one of these equations to find how much the time to pass from initial to final positions. Okay, I will not compute the distance passed. I can use this equation, which is the first one. V final is equal to V initial plus A multiplied by T. I need to compute T. I have the acceleration, which is -2. This is minus. This is 2. V initial, it is the same like this one, 1.75. V final, it is 0. 1.75. Okay, how can I find T now? Now I have this equation, 0 equal to 1.75 minus 2T. I can move this -2 to the other side. It will be plus 2T is equal to 1.75. I can divide over 2 over 2. From that I can find T is equal to 1.75 over 2, which is equal to half. I will compute it. Which is equal to also 108, 0.875 time in seconds. Okay, now I can use any one of these equations to find the change in position over the hill. I will not use this one. I will not use this one because there's no any acceleration in this equation. I will use this one. I find the time. I know the time. I know V initial, which is this one. V final is 0 and I don't need it. X initial, I can suppose that this is X initial is 0 and I can use this for the equation. This example is solved now. What if I need to solve another example? A student, the first step, I need to read carefully the question. Then I need to know what is the law that I need to use. The third step, I need to know how to substitute each number from the understood question in the place of the samples and the quantities. Then I need to simplify my equations and find the last answer with the units, with the direction if it is needed. I have a time, it is directionless, it is scalar quantity. Now, this example, a student moves on a bicycle at a steady acceleration. Its acceleration is, the acceleration is equal to plus 1 meters per square second. To reach speed v final, v final is equal to 7.5 meters per second. Okay, if the bike displacement is during this time is x equal to d, which is displacement, so x or delta x, which is equal to x final minus x initial, is equal to 19 meters. I need to find the initial velocity. Look, the first equation does not have the change in position. The second one is also I can't find the change in position. The third one is third one have the position and the velocity and the time. The third one have the time and the velocity and the position. I don't have the time in my equation, so I need another equation, which is the last one, which have v squared is equal to v0 or v initial squared plus 2a delta x. Okay, I will use the last one. I will write it here. V final squared is equal to v initial squared plus 2 multiplied by the acceleration, which is constant and uniform in our case, multiplied by delta x. Delta x is given, the acceleration is given, v final is given. I need to compute v initial. But be careful, I have in this case v final squared. So I will put 7.5 squared is equal to v initial squared plus 2 multiplied by the acceleration, which is 1, multiplied by the change in the position, which is 19. Okay, this value 7.5 squared is equal to 56.25 is equal to v initial squared plus 2 multiplied by 19 is 38. Okay, I need v initial. I can add and subtract 38 from both sides, or I can move this value to here. It will be 56.25 minus 38 is equal to v initial squared. Okay, v initial, no, v initial squared is equal to 18.25 meters per second squared, because the velocity is squared here. Now I need v initial, so I have to take the square root of 18.25, which is equal to two values, plus 4.27 and minus 4.27. Okay, of course meters per second. I have to accept one of them, because my movement in the positive direction, not the negative direction, I have the positive initial velocity. Because if I have the negative initial velocity in this direction, then v initial here, v final here will be in the negative direction, not in the positive direction. So I will neglect this one and I will accept v initial is equal to 4.27 meters per second, and the final velocity is 7.5. That means that body is accelerating. Okay, this is the second using this equations. We have also this example. You can do the same as what I did now. I will use this equation, the fourth one. No, it is not clear enough on the video. I will fix that. But the acceleration in this equation in y direction, the acceleration for free falling bodies, for this is a free falling body, the acceleration of it is 9. The acceleration downward to the center of earth, if this is earth, the acceleration is equal to g due to gravity, which is equal to 9.8 meter per square second downward. That is depend, I can take it positive or negative, but in general we take the upward in positive direction and the downward in negative direction. So I will take g is equal to minus 9.8. This is simple. For this example, I need to find the depth of the well. So the depth will be downward. It is delta x or delta y or h or d, but it will be downward. In this case it will be negative value, and I need to use the g, the acceleration due gravity, which is g, and put it 9.8, and the initial velocity for free falling bodies, this is the pen free falling body. You see that on the videos. The initial velocity is 0. V initial, I will put it 0. I can find the V final, and I can find the depth, and I can find anything I need. Okay, the last sheet, it is the question in page number 42. We need to understand the question and you can find the solution easily. We have a crocodile at the position of 0, and its equation of motion x of it is equal to 0.25 multiplied by t squared. We have two ducks. They are away from him 3 meters. This is 1 meter. This is 2 meters. This is 3 meters. Look. The first one, it has a position at 3 meters, but its position reduced by this rate. So the first one, the position reduced, it is coming toward the alligator. Okay, so the first one has the equation of motion for d1, for duck 1, is equal to 3 minus, I will not put the units now, minus 1.5 multiplied by the time. The second one is going away from him, so x for the second duck is equal to 3 plus 1 meter per second multiplied by the time. Okay, now the change in position for the alligator is in positive direction. The time is positive always, and the constant here is positive, so the crocodile and the alligator is going to the positive x direction. We can find that the first duck will meet it at first, then he will find the second duck after a period of time. We can calculate this. If you need, visit the office hour and I will solve this question with you. Also, you need to remember that where's the first sheet? The first sheet. This is it. Yes. When we use the functions in mathematics, in physics, we need to use these functions to find the position for each animal. Try it. If you can't do that, just meet me in the office hour, and thank you. Meet you in the next examples.